Hi guys, welcome back to my channel. Today we are going to go over the homework from lesson 2C-2. All right, number 1, graphically solve the system of equations. So we're going back to what we did on Tuesday, and these are equations because you can clearly see the equal sign. All right, so our first step is always to get each equation in slope-intercept form. So here are our two equations. We're going to start off by bringing all the x's over and rewriting the rest. Now we see that both equations are set equal to y, so we're ready to graph. For our slopes, we have -1 over 1, so that means down 1, right 1. For this one, we have -2 over 1, which means down 2, right 1. And here are our y-intercepts. So I'm going to graph the first line, y equals -x plus 2 first. Since it's just a regular equation, I'm going to connect it with a regular solid line, and I'm going to label it y equals -x plus 2. All right, so that's how you graph the first one. Let's do the same thing with the second one. I'll do that one in red. So honestly, at first, I was plotting the ones on this side, and I was like, okay, where is this going? I don't see any point of intersection. But if you go the opposite way, up 2, left 1, up 2, left 1, up 2, left 1, we eventually see that right here is our point of intersection. So at this point right here, that's where our two lines are going to intersect, and that is at, we have -3 on the x and +5 on the y. So that's our solution. We just got to add this little finishing touch over here by labeling our line. So we have y equals -2x minus 1. So we are good. Next question. Which ordered pair is the solution of the following system of equations? So there's a couple of ways that we can do this. To me, the easiest way would be to plug everything in. So I'm going to do each choice in a different color. So first I'm going to test out choice 1, which is 2, -1. Now, if it's a solution, that means when I plug in 2 for x and -1 for y, I'm going to get 2 true equations. So I'm going to start by writing both equations. Okay, so we set ourselves up for success over here. And I'm just going to substitute in for my y, which comes first, the -1, and then a 2 in for x. So for both equations. So here, the x comes first, so I'm going to put the 2 in there and the -1 here. So let's figure this out. -1, put this part in your calculator. That cancels out. -3 plus 2 is -1, so it works for this first equation. But is -2 plus -1 equal to 12? I think not.
The bus is leaving in 5 minutes.
Oh gosh.
You're taking
The bus.
Come to the bus.
Better get on that bus. All right, so this doesn't work. So since it doesn't work for both, 2, -1 is not a solution. So I'm going to go ahead and work out the rest of them until I find the solution. So you set it up, and then you're going to plug in your numbers. Now guys, right away, look over here. I'm not even going to do all this. Look over here. That's going to be -2 minus 5. That does not equal 12. So this is out. Now we're going to test out the points -4 and 8. So we have 8 is y, -4 here. Then we're going to have -4 in here, and then 8 there. All right, so let's take a look at the second equation first, because that was where both of these messed up. All right, so we're going to have a +4. Negative turns positive. Plus 8, that equals 12. So that works. That's a true equation right there. Now over here, we're going to have -3/2 times -4. If you put that in your calculator, what you're going to get is that should be actually positive 6. And 6 plus 2 is 8. All right, this created a true equation on this side of town. And then we had a true equation over here. So the ordered pair, that is the solution, is negative 4. Now, this works because when you substitute in negative 4 for x and 8 for y, it creates two true equations. And there you go. Okay, so now we're graphing inequalities. Same beginning. We're going to add the 3x to the other side. So we have 2y is greater than 3x plus 6. Divide everything by 2. So y is greater than 3 over 2x plus 3. So your slope is 3 over 2. That means up 3, right 2. Your y-intercept is positive 3. So when we're graphing that, we start up here, and we're just going to make the points only for now. Remember, we either have a dotted or a solid line. We don't know yet. Oops. All right, so the line type, since it is greater than, all right, it's going to be dotted. So our line is going to be dashed or dotted, whatever the heck you want to say. And I have to label it. Y is greater than 3 over 2x plus 3. Okay, now the shading, my shade. Which way am I throwing my shade? If it's greater than, we're going to shade up. Now, remember, the dotted boundary line is like an open circle. So any point that is on this is not part of the solution, but every point within the shaded area is part of the solution. So it says, is the point negative 3 comma 10? Let's do that in a different color. Let's do that in, I don't know, black. Okay, negative 3 comma 10. Negative 3, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that part of the solution? Yes. It falls within the shaded area or region. Potato, potato. Okay, now this last question says, is the point 6 comma 12 a solution to the inequality? Prove algebraically. Oh shoot. So prove algebraically means we need to first copy down that original, which was 2y minus 3x is greater than 6. Okay, and we're going to substitute in 6 and our 12. So 6 is our x, 12 is our y. Always do the original, the OG, okay? So we have 2 times something minus 3 times something is greater than 6. Let's see if that works. So 2 times y comes first. 2 times 12 minus 3 times x. We have 24 minus 18. Is that greater than 6? Well, 24 minus 18, last I checked, is 6. Now, don't you dare fall into that trap. Is 6 greater than 6? No. No, it's not greater than 6. 6 is not greater than 6. Don't fall into the trap, okay? The more you know. This does not work. So that means 6 comma 12 is not a solution. And it's simply because when you substitute in 6 for x and 12 for y, this is not a true statement. Okay? Well, that's your homework, guys. Have a good one. Thanks for stopping by. Like, comment, and subscribe. Bye-bye.